Okay, right where we left off, we were at G, melting. Melting a candle is going to be physical. Melting is still the same substance, just like if you were to melt chocolate or melt an ice cube, it's still the same substance, so that is physical. Burning sugar. Burning is definitely going to always be a chemical change. Burning is not the same thing as heating. You can heat something and still have the same substance. But if you burn it, it is going to be chemical. And finally, water evaporating into a glass. Evaporating is still the same substance. It's turning from a liquid into a gas. But it is still going to be H2O. So that is definitely going to be physical. Number 25. Why is the formation of bubbles an indication a chemical reaction has taken place? Because bubbles are made up of gas. And gas is one of the signs of a chemical reaction. That's the city girls. That's the girls in our mnemonic device that we taught you.
Number 30, in an experiment, 2 flasks of unknown clear liquids are combined in a beaker, and the following observations were obtained. So we've got 2 clear liquids. So the 2 clear liquids remain clear, so there wasn't any color change. That should be something that's physical. P for physical. The amount of solution in the beaker increased. Well, that would make sense because you're combining 2 clear liquids, so the volume is going to increase. The solution temperature changed from 10 to 20 degrees Celsius, so that is a temperature change, which was one of our chemical evidences, or evidence that a chemical change took place, so that's going to be chemical. Some of the liquids remained inside the flask. Well, that's just because they didn't pour it all out. That's going to be physical. How many of the listed observations indicate that a new substance was formed? That's going to be 1, which is going to be the temperature. Number 31, an experiment is performed in which a crystal-like substance is added to a beaker filled with room temperature water. The following observations are made. All of the observations are evidence that a chemical change took place except the crystals dissolved. Okay, dissolving, we said earlier, is a physical change because those crystals may dissolve in that water. However, if that water were to be evaporated out, left outside for a couple of days, the crystals would be still at the bottom. So that is going to be a physical change. A precipitate, that's the part of the city, the phones. So city girls love their cell phones on, P, so that it's going to be a chemical change. The bottom of the beaker feels warm to the touch. That's going to be temperature, which is going to be temperature change, which is going to be a chemical. And bubbles begin forming within the water. So bubbles over here, that's a gas, and which is also a chemical change. So this one here is the correct answer as far as the physical change. And then number 32, in which of the following examples has a chemical reaction occurred and why? So we're looking for a chemical reaction. So one of the city girls love their cell phones on. After putting liquid batter in a hot pan, the batter solidifies and begins to turn brown. So sounds like they're making some sort of a pancake, and it changes into a solid. That's a physical part, but begins to turn brown. This is a color change. So this is a possible chemical, but we're going to go ahead and keep going. After turning on a blender filled with fruits, the fruit is chopped up and mixed together. Chopped up is going to be physical, mixed together is physical. After taking a tray filled with ice cubes out of the freezer, the cubes begin to melt. Well, it's no longer frozen, so melting, it's still water though, whether it's in frozen or liquid form. After adding a spoonful of sugar to a mug of hot coffee, the sugar dissolves completely. Dissolves is physical. So the correct answer here is going to be this first one. turning brown.
All right, counting atoms, directions for each problem. Number 1, we always told you to write down all of the elements in the compound. We recognize the elements by capital letters. And the capital letter, if it's next to a small letter, the small letter has to go with the capital letter. Ask the 3 questions for each element to calculate the number of atoms. So remember our 3 questions. Is there a subscript? Is there a coefficient? And are there parentheses? If the answer is no, then we're going to write a 1. Here are 3 examples. Since we're going to do this with you, I'm not going to go through the examples. So the first one we're going to do is NaOH. Na, the A goes with the N because it's small. And of course we have O, which is oxygen, and H, which is hydrogen. First question we ask, is there a subscript? No, there is not a subscript, so we put 1. Second, is there a coefficient? No, there is not. We put 1. Are there parentheses? No. So 1 times 1 times 1 is 1. Oxygen, there is no subscript, there is no coefficient, and there are no parentheses. Hydrogen, there is no subscript, there is no coefficient, and there are no parentheses. So there's simply one atom of each of those 3 elements. Okay, number 2, we have 4H. Oh, and so the total atoms would be 3 total atoms in this molecule. Number 2, we have 4HNO3. First step is to write down the 3 elements in this particular molecule. Then we start asking our question. There is no subscript. There is a coefficient of 4. There are no parentheses, giving us 4 hydrogen atoms. There is no subscript. There is a coefficient of 4, and there are no parentheses. So we also have 4 nitrogens. Oxygen does have a subscript of 3, so we're going to multiply that times the coefficient of 4 times 1 for no parentheses, giving us 12 oxygen atoms. So we have a total of 12 plus 4 plus 4, which would be 20 total atoms in this molecule. Number 3, we have Mg and Cl. Magnesium, there is no coefficient, no subscript, no coefficient, no parentheses, so there is only 1 magnesium. Chlorine, we have a subscript of 2 with no coefficient and no parentheses, so there are 2 chlorines, giving us a total of 3 atoms. And finally, over here, we've got lithium and oxygen. Lithium has a subscript of 2, a coefficient of 4, no parentheses, so there are 8 lithiums. Oxygen has no subscript, a coefficient of 4, and no parentheses, giving us 4 oxygens for a total of 12 atoms in this molecule.
Okay, number 5, we've got some parentheses here, but first, MgCl, be careful with that L. It's usually chlorine and not carbon and iodine, so most likely it's that. Okay, magnesium, no subscript, so 1, no coefficient, so 1, and it is not part of the parentheses, so 1 as well. Total of 1. Chlorine, subscript of 1, no coefficient, so 1. It is part of a parentheses, so we look at the subscript of that, which is going to be 2. 2 total chlorines. For oxygen, it has a subscript of 3. There is no coefficient, so 1. It is also part of the parentheses, so its subscript is 2, of a total of 6 oxygens, and that's going to be a total of 9 total atoms. This one, Li2SO4, so we've got lithium, sulfur, and oxygen. Lithium has a subscript of 2, no coefficient, so 1, no parentheses, so this is 2 lithiums. Sulfur, no subscript, no coefficient, and no parentheses, so 1. Oxygen has a subscript of 4, there's no coefficient, and there are no parentheses. So total atoms here is going to be 7 total atoms. All right, number 7, 4ZnOH. So I've got zinc. That N goes with the zinc. So 3 elements. And zinc has no subscript. So 1, its coefficient is 4, and it is not part of the parentheses, so 1, total of 4. Oxygen has a no subscript, so 1, coefficient of 4. It is part of the parentheses, and its subscript is going to be 2. That has a total of 1 times 4 times 2 is 8. Hydrogen, subscript of 1, coefficient of 4, does have parentheses, its subscript is 2, that is also 8. So a total here of 20 total atoms. Number 8, I've got Na, C for carbon, H for hydrogen, and O for oxygen. Here I've got 1 subscript, no coefficient, no parentheses, so 1. 2 subscript, no coefficient, no parentheses, so 2. Subscript of 3, no coefficient, no parentheses, so total of 3. Oxygen, 2 subscript, no coefficient, no parentheses, so 2. This is a total of 7 total atoms.
Okay, number 9, we have 3Al2O3. Al is aluminum. It's not going to be, there is no element. It's just capital A, so it's not going to be capital A, capital I. It is Al. Then we have O, which is oxygen. Al has a subscript of 2, a coefficient of 3, no parentheses, so we have 6 aluminums. Oxygen has a subscript of 3, a coefficient of 3, no parentheses, giving us 9, for a total of 15 total atoms. Number 10, we have N, H, and Cl. N, it has no subscript, it has no coefficient, and no parentheses, so there's 1 nitrogen. H has a subscript of 4, no coefficient, no parentheses, giving us 4 hydrogens. And chlorine has no subscript, no coefficient, and no parentheses, giving us 1 chlorine for a total of 6 total atoms. Number 11, we have 5, ZnSO4. So we have Zn for zinc, S for sulfur, and O for oxygen. There is no subscript on zinc. There is a coefficient of 5. There are no parentheses, giving us 5 total zinc atoms. Sulfur has a coefficient, no subscript, which is 1, a coefficient of 5, and no parentheses, giving us also 5 sulfurs. Oxygen has a subscript of 4, a coefficient of 5, and no parentheses. 4 times 5 times 1 is 20. So this molecule has a total of 30 atoms. And number 12, finally, we've got Zn, which is zinc, P, phosphorus, and O for oxygen. Zinc has a subscript of 3. It has no coefficient, and it is not part of the parentheses. So 3 times 1 times 1 gives us 3 zincs. The P is inside the parentheses. It has a subscript, no subscript, so it would be 1, no coefficient. And the parentheses has a subscript outside the parentheses of 2, giving us 2 phosphorus atoms. And oxygen has a subscript of 4, no coefficient. And then, of course, that it's inside the parentheses, so the subscript of 2 would be multiplied. 4 times 1 times 2 gives us a total of 8 oxygens, giving us a total of 13 atoms. Okay, guys, so that concludes our benchmark review. It is extremely important that you complete this review. It's important that you study it. If you have any questions or need any help, you need to refer to the videos. You need to come into tutoring. You need to look at the other resources we have provided for you in Google Classroom. This benchmark is going to help us determine what groups you're going to be in for our tutoring after the break, for pullouts that we're going to be doing. So we're going to want you to do your very best on this. If you get this completed and signed by your parents and turned in before we take our benchmark test, you will get 10 extra credit points added to your test that will go in the grade book. We are counting this benchmark as a test grade. So you're going to want to do your best. Think of it like a final exam for the semester. Please do your best. Good luck, and let us know if you need help.